Okay, this is just a quick lesson on how to use Avogadro's number to calculate conversions between particles and moles. First of all, we know that 1 mole is equal to 6.02 times 10 to the 23rd representative particles, and those particles can be ions, atoms, molecules, or formula units. Those are some of the different words that you might hear when they're talking about particles, so you're up here. And we're trying to convert it to moles. When we go from moles to particles, we're multiplying by Avogadro's number. When we go from particles to moles, we're dividing by Avogadro's number. So an example problem can be found on this worksheet, the mole and Avogadro's number. How many molecules are in the quantities below? If we're given 2 moles, start your fence post with 2 moles over 1. And then in 1 mole, there are 6.02 times 10 to the 23rd molecules, because this worksheet just asks us for molecules. So that's the setup for our problem. The units, moles, will cancel out. And on your calculator, try to get that where you can see. Multiplying 2. Oh, hello, turn it on first. It's 2 times, get my fingers up here so you can watch. Sorry. So I'm doing 2 times 6.02 second, comma, that gets that little yellow EE right there. Notice how it shows 1 E on the screen, 23, enter. And the answer is 1.204 times 10 to the 24th. The 2.0 in our problem was 2 sig figs, so we're going to round it to 2 significant figures. So our answer should be 1.2 times 10 to the 24 molecules, which is a lot of molecules. Let's do another problem. This time we're given 1.50 moles. So 1.5 moles over 1, because you want your given over 1. We're trying to change it into molecules. So 1 mole on the bottom, 6.02 times 10 to the 23rd molecules over 1 mole. Moles cancel out, and that gives you 6.02 times 10 to the 23rd times 1.5 moles. To get to molecules, sorry. So let's put it in here. 1.5 times 6.02 second, comma, to get that little E, 23, enter, 9.03, let's make it 2 sig figs, so 9.0 times 10 to the 23rd molecules. Okay, and then you continue just like you do on the rest of the way down. Let's try one at the bottom. How many moles are in the number of molecules below? Well, notice this one, number 1, is 6.02 times 10 to the 23rd. That's the same as a mole. So I didn't even have any math to do there. That's just reasoning out to see if you recognize the number. But what about the next one? How many moles in this number of molecules? So this number of molecules over 1. I'm trying to get to moles, so I want molecules on the bottom to cancel out. Okay, and I know that in every 1 mole, there are 6.02 times 10 to the 23rd molecules. So this time I'm going to be dividing. Let me move the calculator up a little bit so you can see what I'm punching in here. I need to zoom out a little so you can see the keys. Okay, so for this one, I'm going to do 1.204 here's the fancy thing, the second button, and then the comma to get that little yellow EE, 24, divide by 6.02, second, comma to get the E, 23, enter. And the answer is 2. That's 2 moles. I still want at least 3 significant figures though, so I'm going to write 2.00 moles. Okay, how about the next one? Next one is 1.5 times 10 to the 20th molecules, and we want to find how many moles that is. So again, there are 6.02 times 10 to the 23rd molecules in 1 mole. And I'm going to be dividing. So 1.5 second, comma, 20 divided by 6.02 second, comma, 23 is 2. Now look at that. 2.49, or we probably want to round that to 2 sig figs. So 2.5 times 10 to the minus 4 moles. Sometimes you get in the habit of thinking if the number is scientific notation, that automatically makes it particles. But remember, this is just a number. It's the same thing as 0.00025 moles. Just a small fraction.